Okay, so this is from page 616 of your textbook. It's number 28. You can use it to solve Dr. Padgett's number 2 question on her exam sample problems. So the question reads, what mass of HClO4 should be present in a 0.500 liter of solution to obtain a solution with each pH? So we'll start with A, pH of 2.50. So it's asking for mass, and mass is will be in grams. And so you'll have to use your periodic table in order to derive the grams. But first, let's find the concentration of what we have here. So we have pH is 2.5. Recall this equation. pH equals negative log of H plus. And on the side here, I'll just remind you that H plus equals H3O plus equals hydronium ions equals protons. Okay, so we'll plug this in. So 2.50 equals negative log H plus. So what I do is I like to multiply the entire thing by -1, the entire equation, so it will read negative 2.50 equals positive log H plus. And then to get rid of that log, you would put 10 to the negative 2.5 and 10 to the log of H plus. So log and the power of 10, they are inverses. It's like an exponential, so they're inverses. You can actually just cross that out. They'll cancel each other out. So 10 to the negative 2.50 will give you your proton concentration. And I found that to be 3.16 times 10 to the negative 3. Okay, so now we have our concentration. Our concentration is going to be in molarity. So that's capital M. That's also mole per liter. And we can use this conversion to do another conversion of grams per mole using the periodic table. And so I'm just going to tuck this information away and use a periodic table to derive my grams per mole. So if I look at the periodic table, hydrogen weighs 1. And I'm looking at hydrogen because I'm getting it from HClO4. Chlorine weighs 35.45. Is that right? Yeah. And oxygen weighs 16. Now we only have 1 hydrogen, we only have 1 chlorine, and we have 4 oxygens. So this will be 1. This will be 35.45, and this will be 64. Then you will add these all together in this column to get 100.45 grams per mole of HClO4. Okay, so now we have all our ingredients to find the mass. We'll take 3.16 times 10 to the negative 3 moles per liter. You'll multiply that by the number of liters that you're given. So remember, it asks what's the mass that should be present in a 0.500 liter of solution. So it's already in liter. We don't have to do any converting like for milliliters or anything like that. So you can just go ahead and put that right here. Okay. And so when we do this multiplication, our liters are going to cancel and just give us moles. But let's keep going. So we just found out our grams per mole here, and we want to keep grams. We want moles to cancel out, so you want moles in the denominator, so it cancels out with this mole here. So that's 100.64. Oh, said moles so much, I started putting them in the wrong place. Grams per mole. Okay, so now we can do some canceling out. This liter will cancel with this liter. That mole will cancel with that mole, and you'll only be left with grams. And I got 0.1. What are the sig figs here? Is that three sig figs? So 0.159 grams of HClO4. 0.159 grams is our answer. Okay. Okay, so now let's do B. pH is 1.50. So we'll do it the exact same way. 1.50 equals negative log of H plus. I'm going to rewrite this by multiplying the entire equation by negative 1 to get negative 1.50 equals positive log of the hydronium ions or protons concentration. And that gives me 3.16 times 10 to the negative 2. That is my H plus concentration. Remember that concentration, these brackets are molar, and that equals moles per liter. So now we can use 3.16 times 10 to the 2 moles per liter multiplied by 0.500 liters, which is over here, what is the mass of HClO4 that should be present in 0.5 liters of the solution. We multiply that by our grams per mole, which we found earlier, 100.45 grams per mole. Our liters cancel, our moles cancel, and we're left with just grams. And we have 1.59 grams per mole. Nope, sorry, just grams. Sorry, we canceled our moles. Just grams. Good. C is a pH of 0.50. So 0.50 equals negative log of H plus concentration. We'll rewrite that. So I don't have a negative log, and then I'll put this to the power of 10. So that cancels out, and so my H plus concentration will be 3.16 times 10 to the negative 1. This is in molar, which is moles per liter. So I can multiply it by the liters in the problem. Let me actually put my units in there. My liters in the problem, 0.5, so that's 0.500 liters. And multiply it by my grams per mole that I derived from the periodic table. Alright, so liters cancel, moles cancel, you're left with grams. And we get 15.9 grams. Okay, so you might notice a pattern. So each shift in one entire pH gives us a place shift with our decimal. That's not a coincidence. P is a negative log, and a log is an exponent of 10. So that's a pattern that's notably recognized. Okay.